In this video, I will show you how to match a graph like this one to its equation. In order to do that, we first must familiarize ourselves with a few parent functions. For example, you should know basically what the graph of y equals x squared looks like. You should have this memorized. Y equals x squared is a parabola that's going to look like this. Now, another parent function that is closely related to this is the function y equals the square root of x. And that will be a sideways parabola, but plot twist, it's only going to be half of the parabola. There are two more parent functions that you're going to need to be familiar with. And the next one is y equals x to the third power. So this graph makes a wave like this. All right, that's sort of like half a parabola right there, and then it makes the other half of the parabola going up. Right in the center, this is called an inflection. But that's what the parent function y equals x cubed looks like. So what about the cube root of x? Well, notice how the cube root, we had x squared, it was a parabola. The square root of x was a sideways parabola. Similarly, the cube root of x is going to be a sideways wave. So the wave is going to look like this. It's the same shape as x cubed, but it's turned sideways. So y equals the cube root of x. So these are the four parent functions that I need you to have in your mind as we look at this problem. So look at the graph they gave us and decide which of these four parent functions it is similar to. Hopefully you can see that it is very much like a cube root graph. It is a sideways wave. So we can immediately eliminate these two options. These are not, this is not a square root graph, so we can throw these out. So it's going to be one of these. So next you need to know about transformations. The plus 3 on the end of both of these equations will take the parent function and shift it up by 3. Because they are both shifted up by 3, we can't use that to help us choose. So turn your attention to the inside. This one has a minus 3 and this one has a plus 3. When you have a number being added or subtracted inside the function, this is going to be either a left or a right shift, and it's going to be the opposite of what you would probably think. So a minus 3 will actually be a shift to the right 3, and plus 3 will actually be a shift to the left 3. So compared to the parent function, is this graph shifted to the left or to the right? Obviously, it's here to the left. It started out at the origin, it moved up 3 and to the left 3. So that means that the last equation is the one that fits. Bam! Check it out.